So to solve this equation, we're going to need to use the quadratic formula, which is, of course, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know you guys just love to hear that. And so I've identified the value of a, b, and c. I'm going to plug them all in. Now when I do the b squared minus 4ac, we remember that's called the discriminant. And so if I take 8,000 minus 4 times 1 times negative 810,000, I forgot a zero, I get a discriminant equal to a very large number, 672400000. Okay? That's my discriminant. That's what's underneath the radical. When I take the negative b, plus or minus that square root of the discriminant, and put it over 2a, that would be over 2 times 1, which is 2. Now we know to simplify this, we merely need to figure out the value of the numerator with the minus and divide that answer by 2. Then figure out the value of the denominator with the plus, or numerator with the plus, and then divide that answer by 2. And what we end up with in this case is two values. We find that h can equal either negative 8,100 miles, which of course is not possible because you can't have a negative distance, or h can equal 100 miles. And 100 miles then would be our solution. Okay? Now we want to check to make sure that it does in fact work out. So if I go back to this original equation and I replace each of these h's with 100, so type in 100 squared plus 8,000 times 100 minus 810,000, it needs to come out equal to 0. If it doesn't, it is an extraneous solution. But in this case, it does. Okay? Examples are going to be much more doable in terms of the value of the numbers we're working with. We want to find all the solutions to this equation. And so the first thing we need to do in solving an equation that involves a radical is you've got to get that radical alone. So I've first got to subtract 2 from both sides. And I would have the cube root of x is equal to 7. And then to undo cubing, you have to use the opposite, to undo cube rooting, you have to use the opposite operation, which would of course be to cube. And in this case, we end up with x is equal to 7 cubed, which is 343. But the question is, does it work? If you go back to the original and you replace x with 343, we want to see if it does in fact come out equal to 9. Well, the cube root of 343 is 7, and 7 plus 2 does equal 9, and so 343 is the solution. Okay? In example 3 here, again, we want to start by radical alone. And this equal is supposed to be in front of the 80. So let me rewrite this. I've got 5 times the square root of 3y plus 1 is equal to 80. So I have to move that 5 first. It's being multiplied by the radical, so I'm going to need to divide. And I'll get the square root of 3y plus 1 is equal to 16. Now this time I have a square root, not a cube root. So now the opposite of square rooting is to square. And I end up with, on the left, 3y plus 1, and on the right, 16 squared is 256. To solve for y, I need to subtract 1 from both sides. And then divide both sides by 3. And I get y is equal to 85. But this equation involves solving an equation with a radical, so I have got to make sure it works. If I take 5 times the square root of 3 times 85 plus 1, I want to make sure that that is in fact equal to 80. Well, When I type 5 square root 3 times 85 plus 1, it does check out, so my solution is in fact y equals 85.